video, we're going to be looking at topographical maps and how they use contour lines to represent elevation changes. We notice in the middle of our screen, this is Pikes Peak, one of Colorado's highest mountains. It ranks number 31. It stands 14,110 feet above sea level at its summit. As we work away in the video, we notice that the lines continue to follow the center line outward. And we notice that as the lines are closer together, this represents steeper areas of the mountain. We'll also notice that on the left-hand side of our screen, we see the road that travels up to Pikes Peak. If you notice, the road travels up the gentler side. We're going to see how we can make our own map using a clay model to represent a mountain. Okay, today we're going to be using air dry clay, and it's made by Crayola. It's not very expensive, but the nice thing is that it's very easy to mold, and we can actually cut it easily with dental floss. Now, when we're done with our air dry clay, we want to make sure we put it back in a container so it does not dry out. So taking a large hunk of clay, we're going to actually build a mountain so that we can create a topographical map so students understand how these maps can create or show three-dimensional elevations. Okay, the main thing I want to do when I'm creating my mountain to represent the map that we're going to make is I want to make sure that it has different elevations within the mountain itself. I also want to make sure that we have steep areas as well as gradual sloped areas so that we can see how those will appear on a map as we create it. Now, one thing I want to make sure I do is I have a higher peak or more than one peak on the mountain that I create, so we can see that the contour line for that particular peak is a complete circle within the center showing the highest elevation. So once we have it molded, we want to make sure that we press it down firmly to the paper. That way it has a tendency not to slide as easily. The next thing we're going to do is take a pretty long piece of dental floss, and the dental floss is what we're going to use to actually cut away our mountain in cross section. Okay, so we just take our dental floss and we just slice it through a cross section of the clay, and we want to make sure that the thickness that we cut the first line through is approximately the same thickness we'll cut every additional line through. So we're going to set this top part aside, and then I want to make sure the students are aware that this side edge is about 100 feet or 50 feet, whatever it is you want to use for your measurement. So every time we make a cut, that's an additional 100 feet in this case that our mountain has been elevated or that we're going up the mountain. So taking a marker or pen, we're going to trace around the outside edge of this first base plate. Now this first base, because students are still trying to understand elevation, let's make sure that we, for this first round, show that this is at 0 feet, which means it's at sea level, basically. So basically this would be a mountain range sitting at the edge of the ocean. And then we're going to take our top piece and set it on top of where we just took our bottom piece off. Now we don't want to destroy these pieces because we're going to actually rebuild our mountain at the end to compare the three-dimensional model to our drawing. So taking our dental floss once again, we're going to slice the same thickness as we did before. So basically we are coming up 100 feet from that original line. Okay. Now because the bottom of this piece matches to the top of the previous piece, this would be 100 feet up from our original drawing. So we have 0 elevation, then the second line that we're drawing right now would be 100 feet higher. Now, of course, if we're in a country outside the United States, these would be measured in the metric system, so in kilometers. Okay, so make sure our line touches. These are going to be our lines that represent the elevation. Now we're going to take our next part and put it back in again. So we're going to repeat the same steps, and we're going to cut it once again. Sometimes it's helpful when you have a second person to kind of hold down to prevent it from sliding. So remember to keep our same thickness that we cut the previous piece to, so that each piece represents a 100-foot elevation. Okay, set this part aside for later and go ahead and trace out our outline around this. So our first circle was 0 feet. Our second one is 100 feet. So this circle now represents 200 feet above sea level. Setting this one aside for later, we're going to take the top part again, set it back into our circle that we just made, and we're going to cut it once again. Now these circles, by the way, are called contour lines. And contour lines basically just say that they follow the topography or the outside edge. Okay, set this top part off again, and let's trace around that one more time. Okay, so our first line would be 0 feet, then our second one was 100, then 200, so now this line represents 300 feet above sea level. Okay, continuing the same steps, continue to put our mountain back in position each time and trim off another layer the same thickness as the first layer that we started with. Set that aside and let's trace once again. Okay, so this particular line would represent another 100 feet up from our previous line. Continuing with the same process, replace our mountain top that we have, put it back into the contour line, and let's trim it again. Okay, repeating the process of tracing once again, this contour line we're going to do in blue, not because it's any different, it's just that my previous pen came in contact with the clay and was not writing as well, so color has no difference here. And we're going to set that one aside and then take our peak and place it in the center, and we're going to go ahead and trace around it. Now we're not going to cut another section of this because it's approximately the same thickness as all the other pieces we've been using. Okay, setting everything aside, let's go ahead and label the elevation. So our first layer was 0 feet at sea level, then 100 feet, 200 feet, 300 feet, 400 feet, 500 feet, then finally 600 feet above sea level. Now if we notice, these lines on the sides are really close together, and so these lines represent a steeper angle of our mountain. So the best way to represent this for the student is to rebuild the actual mountain. So remember this, the bottom layer was at 0 feet, so right above it, this part here was 100 feet. This layer would represent 200 feet, and then this next layer 300 feet, then 400 feet, 500 feet, and then 600 feet. And we can go ahead and put this peak on. We could have drawn this little part right here, which would have made the mountain actually about 700 feet above sea level. And so these steep sides right here, we're going to see how these lines look compared to this slanted side here. So when the lines are close together, we have a very steep angle. And then when we see that the lines are far apart in certain areas of the mountain, they're not as steep as these. So this part right here would be a less steep angle. This would be the way I'd want to hike if I were hiking up this mountain. So looking at it here, we have a slightly sloped area and then a very steep sloped area. And so these are represented basically by how close the lines are together. This also shows us the way that water would run off in snow. And so water will run off fast on the steep areas and it will run off slower on the less steep areas. But we always want to know that our topography, our map that we're creating, represents the elevation changes from looking at it from a bird's eye view. So looking at it from the top and just kind of seeing what's going on with the sides and edges of our mountain range.